Alright, for tonight's homework, I'd like you to write down all this work, and there's going to be 3 words to write down. I'm just going to say them just once randomly. Make sure you write them down with the work to show me proof that you watched this and listen. So the work and the 3 words. So here we go. First thing for Module 4, we need you to know that we're solving equations. You need to know your inverse operations. Opposite of adding, subtracting, subtracting, adding, opposite of timesing, dividing, opposite of dividing, timesing. You need to know when an equation has just one variable or when you have both an x and a y in it, and we'll tell you which variable to solve for. Also, problems with just pure numbers or problems with just pure letters using the same math concepts. But here we go. First problem. I'm going to solve for this x. So I'm going to get rid of this 6 first by doing the opposite of subtracting, adding. Those are going to cancel. Bring down 3x, bring down my equal. This is 18. Opposite of timesing by 3, dividing both sides by 3, which gives you x equals 6. That is the solution. Plug in 6 right here. 18 minus 6 gives you 12. This problem different. Blue. This problem you're solving for x, but you have minus 6y here. So the first step, just like I got rid of this 6 over here, I'm going to eliminate this 6y by doing the opposite, adding 6y. Those are going to cancel. Bring down your 3x, your equal. Make sure not to add these up. I could add up 6 and 12 to get 18, but I cannot add these two unlike terms. So I'm just going to write them next to each other with the y term first. And then just like this, the opposite of timesing by 3, dividing by 3, I'm going to divide this side by 3 and divide everything on this side by 3. These cancel away and give me x, gives me, and then a split. I'm going to divide this 6y by its own 3, and then I'm going to divide that plus 12 by its own little 3. I'm splitting that up into 2 little separate fractions, and then I'm going to reduce them. 6y divided by 3 gives me 2y. 12 divided by 3 gives me 4. So you could see huge difference when I have just one variable to solve for or 2 variables. Big difference in the answers. This next problem, solving for x, would be the opposite of timesing by 2, dividing by 2, which will give me x equals, before I divide it out, 8 divided by 2, and that gives me x equals 4. You could write that on this way or on this side, x equals 4. This problem with letters done the same way. If I'm solving for t, the opposite of timesing by r, just like the opposite of timesing by 2, dividing both sides by r. Those r's will cancel like these 2's canceled and leave me t all by itself equals d over r, which is pretty much this same point right here of the problem. But because I could divide 8 and 2 out to get 4, I do that. But with these, I don't know what d and r, so I just leave this alone. Okay, next problem is a graphing problem. Need you to remember how to do these. So for this one, try to draw this graph best you can. I want you to find the domain. Red. So domain is measured from the left side to the right side, left to right, looking at your x-axis numbers from -3 to 3. Since these are both solid circles all the way through, square bracket, square bracket. Increasing is from the bottom to the top. So that would be from 1 through the y-axis up to 5, square bracket, no breaks in the data. Increasing is when you're coming from left to right and you go uphill. Decreasing is when you come left to right and you go downhill. So increasing left to right, going uphill. That's the increasing section. This part, left to right, going downhill, that's decreasing. So going left to right, downhill, decreasing. Going left to right, uphill, increasing. So if I'm asking the increasing part of this data, bordered from left to right on the x-axis, just like domain, from -3 to 1. Square bracket, because these are not open circles. So square bracket on -3 to square bracket 1. Decreasing, this section right here going down, bordered from 1 to 3 on the x-axis, square bracket on that 1 to square bracket on that 3. I need you to know these. F of 1, this is me giving you the x number. X is 1. What is y? So find x is 1 on the x-axis when you see this. Go up until you hit that line, look to the left, and find that y value. So when f of x, when x is 1, y gets spit out as 5. Next one is me giving you the y value first. So that's 2. Don't go to 2 on the x-axis. This is 2 on the y-axis. Find that line and then look down and give me that y number. So if x is 2 or the y value is 2, the x number that had to be plugged in is -2. Know that. Alright, last two. Need to know recursive explicit, arithmetic, and geometrics. So adding by 4, adding by 4, adding by 4, backwards, subtracting by 4. So that would be 10 minus 4, which is 6. The recursive form, f of x equals f of x minus 1 plus that common difference number plus 4. My explicit would be dx plus f of 0. So explicit would be f of x equals 4x plus that y-intercept term, the 0 term, plus 6. Or I could use the first term, f of x equals that same 4, but using the first term I write x minus 1 because I'm shifting to the right, plus use the first term number 10, knowing that these, even though they're different looking, they are equivalent. This is 4x minus 4. That -4 and this 10 give you that same 6. This 4 times x gives you that same 4x. These are equivalent. Different looking, but the same. Yellow, yellow. Alright, this last one, geometric. Timesing by 3, timesing by 3, timesing by 3. Dividing by 3 or timesing by 1/3 to the left gives me 2 times 1/3 is 2/3. So my recursive form, f of x, 0 term, 2/3. 2 times 1/3 is 2/3. Recursive f of x equals f of x minus 1 times 3. That's recursive. Explicit is f of x equals the 0 term, 2/3, times that common ratio 3 to the x power. Or I could shift over 1 to the first term and use f of x equals that first term 2 times 3 to the x minus 1 power. Alright, write down this work and the words. Good luck.